All right, so let's talk a little bit more about projectiles. We said that projectiles are any object that is in free fall, right? So something that is falling through the air. So let's talk about some examples and non-examples. I'm just going to use a ball as our example. So a ball that is dropped would be a projectile. A ball rolling on the ground is not a projectile. Okay, a ball that is kicked would be an example of a projectile. A ball on a ramp is not a projectile. Okay, a ball that is tossed is a projectile. A ball sitting on a table is not a projectile. Okay, so these all have an aspect of free fall, right? The object is falling. That's what makes something a projectile. Okay, now we're going to summarize some of the major ideas that we have talked about with projectile motion. We're going to talk about acceleration, we're going to talk about horizontal velocity, and we're going to talk about vertical velocity. This image that you see here, this shows the trajectory of a projectile, okay? And you'll notice the shape that it takes here, we call that a parabola or a parabolic path. Okay. This is for a basketball, so a basketball that's thrown upwards at an angle, and we can see it's moving to the side, but it's also moving up and down. All right, now I'm going to draw in some vectors here to show, first let's start with the acceleration. So acceleration in this case is the acceleration that we're going to experience is due to the force of gravity. Okay, and it's only happening vertically because gravity is trying to pull things downwards. That's a vertical direction. Okay, so if I draw in, I'm just going to draw in some vectors here. So my ones here in light blue, these are showing my acceleration vector, the acceleration due to gravity. Okay, and so if I look at that acceleration due to gravity, you can see that it's always pointing down, and I use the length of the arrow to show the magnitude, and I didn't measure these exactly, but they're pretty much all the same length. So on the way up, in this case, we know the value of the acceleration due to gravity. It's 10 meters per second squared down, right? That means it's pointing down. So this is the magnitude of it. This is the direction of it. At the very top, right here, that acceleration due to gravity is still 10 meters per second squared down. And if I pick one of these points here on the way down, that acceleration due to gravity is still 10 meters per second squared down. Okay, so this is always, always, always going to be the acceleration due to gravity for a projectile, and it's only going to affect the vertical motion. All right, so now I'm going to jump into horizontal velocity real quick, and then we'll come back and talk about that vertical. Actually, I'm going to jump ahead and talk about vertical, and then we'll come back to horizontal. So let me first kind of sketch in here what happens with our projectile. So we can split the velocity. This line here is the path of it, and the overall, the resultant velocity of our projectile follows that path. But we can split that resultant. Anytime we have a resultant velocity, something on an angle, we can split it into two pieces. So we can split it into a horizontal component, and we can split it into a vertical component. Okay, and so all along here, I can have a horizontal component, and I've got a vertical component. Horizontal component, vertical component. Horizontal component, no vertical component. Okay, horizontal component, vertical component. Horizontal component, vertical component. Horizontal component, vertical component. Horizontal component, vertical component. Okay, so I've got the I've got all of these different lines now. So these are my horizontal components of velocity. Okay. And these are my vertical components of velocity. And you'll notice up here at the top that Vy actually disappears. It becomes 0. All right. So I'm going to, like I said, I'm going to skip down here and let's talk through what's happening with the vertical velocity. Well, you'll notice that the vertical velocity, it starts by pointing upwards. And then if we were to measure the length of these vector arrows, right, upwards and long, and then it's getting a little shorter and getting a little shorter, then it actually goes away. And then as the object starts to fall, that velocity vector starts to grow, but now it's pointing downwards. So it changes in both direction and it also changes in magnitude, right? It keeps getting longer. And so what I would say, my summary of vertical velocity is that it is changing due to acceleration from gravity. So on the way up, right, if I have a projectile, a whole projectile like this, where I'm not just looking at half of it, then what I actually can say is on the way up, what happens is the magnitude decreases. And it's upward in direction. At the very top, right, if you imagine a projectile that you throw, you'll notice that there's a point in its path where it's no longer moving up or down, but it is still moving to the side. And so right up here at the top is where there actually is no velocity, vertical velocity. And then on the way down, the magnitude increases. It starts to go faster as it falls. Right? And it's pointed downwards. All right, perfect. Now let's take a second and check out our horizontal velocity, the one I've done here in purple. So if we check these all the way across, right, we can see that they are always pointing in the same direction and they pretty much look like they're always the same length, right? There's nothing changing about it. And this one, so the horizontal velocity, my summary of that is that it's going to stay constant. Okay, and so on the way, even while this thing is on the way up, the horizontal velocity is constant velocity to the right, right? In this case, the thing is traveling to the right. At the top, it still is that same constant horizontal velocity to the right. And on the way down, it is still the same constant horizontal velocity to the right. So it never changes, okay? So acceleration, you'll see I only drew in an acceleration in the vertical direction. I did not draw one in for the horizontal. If I was to throw this basketball, as soon as it leaves my hand, there isn't a force that's pulling it to the side or pushing against it, since we're ignoring air resistance. And so there's no force to change the velocity in the horizontal, but there is a force changing the velocity in the vertical, and that is the acceleration due to gravity. So this here summarizes what we need to understand about horizontal and vertical velocity and how the acceleration due to gravity impacts that. If I was to put these together, right, I could resolve these vectors, and that's where I would get these velocities here, okay? What we say is that horizontal and vertical velocity are independent. Okay, what that means is that how the object moves to the side, or how the object moves horizontally, is independent of how it moves vertically.